Number 1 asks us to find the number of square units in the area of triangle RST, and we're going to do something called the box method. So what you want to do is draw either a square or rectangle. It depends on what it turns out to be. So that it's the largest either square or rectangle you can possibly draw, so that each of the 3 vertices of the triangle are actually on that figure. So you can see point R is on the top side, point S is on the left side, and then T is in this bottom corner. So this is the largest figure I can draw. It turns out to be a square in this case. So what we're going to do is we're going to find the area of the square. Then we're going to subtract out the triangles that we don't want. We don't want this one in the corner. We don't want this triangle 2 over here. And we also don't want this bottom one I'll call triangle 3. If we subtract triangles 1, 2, and 3 from the square, then we'll be left with triangle RST, and that's what it wants the area of. So the area formula for a square is length times width. And what you're just going to do is count the sides. So if you count, coming all the way down here, you count going across, the length and width both turn out to be 12. So you're just using the graph and counting, and you get 144 for the square. Now we have to find the area of those 3 triangles that we are going to subtract out. Okay, so the first triangle, well, if you go to your reference sheet, the triangle formula, area of a triangle is 1/2 base times height. And watch how I count it, because you want to not count the boxes, you want to count like that length. So the base of the triangle from point R, watch the length of it. It's 1, 2, 3. This is a length of 3, a distance of 3. And then the height of that triangle is 1, 2, 3, 4, 5, 6. And feel free to put those measurements in the diagram if you want to, you can. I usually don't. I just plug them right in the formula. So we have 1/2 of 18, so the area of triangle 1 is 9. And we're just going to keep doing this. If you want to try triangle 2 and 3 on your own, see if you get the same answer as me, feel free. So I'm not going to write the formula, but again, triangle is 1/2 base times height. So for triangle 2, if you count the distance here, we're going to get 1, 2, 3. I know it shows a little bit delayed when I do it here, but 4, 5, 6, 7, 8, 9. So again, I'm not counting boxes, I'm counting that length. From point R to the corner, it's 9. And we already have this distance because this is actually the height here. It's the full side of the square, so it was just 12. Okay, so when you put that in the calculator, you are going to get 54. We have one more triangle left, triangle 3. Again, 1/2 base times height. So let's see, we already know the base, it's this full distance, which is the length of the square, and we already said that was 12. We just need the height. Okay, so let me count this out. 1, 2, 3, 4, 5, and 6. That was 6. So 1/2 of 72 is 36. And at this point, you're just going to take the square, which is 144. I'm going to subtract out those 3 triangles because then I'll be left with triangle RST. So if you add up triangle 1, which is 9, triangle 2, which is 54, triangle 3, which is 36, add those up, you are going to get 99. So when I subtract out the 3 triangles, I get an area of 45. So triangle RST has an area of 45 square units. In number 4, we have a triangle, which I've already graphed, and it says to prove the triangle ABC is a right triangle. Well, you can tell from the graph that here is the right angle, the 90-degree angle. Well, what do we know about a right angle? Well, these 2 sides, BC and AB, they are perpendicular. Okay, so we have perpendicular sides. Well, what do we know about perpendicular lines? We know that the slopes are negative reciprocals, right? So this is what we're going to show, and this is what you do every single time you want to show that you have a right triangle or maybe a quadrilateral that has right angles, anything to do with right angles. We are going to show this, and it's actually just right on your graphic organizer chart that you have. It shows this in there. Okay, so let's do this. So let's start with how about CB. So we're going to take CB, we're going to find the slope of it. So just write down the formula you're using, write down the side you're finding the slope from, and let me put the slope formula. Now we're doing this, although we have the graph to see what everything looks like, we're going to solve this algebraically using formulas. Okay, so CB, let me label XY, XY. So we'd have, I'm going to start with, it doesn't matter which point you start with, even though I wrote CB, you can start with point B, who cares? I'm going to start with point B. So I'm going to do 5 for the Y minus the other Y, which is 9. Go back to point B, whatever you started with. I'm going to do -2 for the X minus the other X, which is 5. 5 minus 9 is negative 4. Negative 2 minus 5 is negative 7. And reduce it down, a negative divided by a negative is a positive, positive 4 over 7. So let's see what happens when we find the slope of the side that it's perpendicular to, which is side BA or AB. Again, it doesn't matter which one that you write. We already have the slope formula. We can just plug it in. Let me just go to point A and label XY over it. I'm going to use point A first when I use the slope formula. So y minus y would be negative 2 minus, now remember, we're doing AB. So if I go to B, the other y is 5 over x minus x. I go back to point A, 2. Now the formula is subtracting, and I'm subtracting a negative 2. Well, subtracting a negative really changes to addition. Negative 2 minus 5 is negative 7. 2 plus 2 is 4. Already reduced down. And look at your slopes. One slope is negative 7 over 4. The other slope is 4 over 7. See other negative reciprocals? They're flipped, but also one of them's positive, one of them's negative. They have different signs. The last thing you want to do, and you always have to do this to get full credit, is you have to just write a little conclusion explaining what you proved. So we showed that it is a right triangle because writing with this thing is not too much fun for me. It is a right triangle because the slopes, and again, you know, this is all in your chart if you kind of need help with what to write. The slopes of, I'm going to say of consecutive sides, meaning, you know, two sides next to each other, because when you do this with a rectangle or a square, it always has to be consecutive sides. So the slopes of consecutive sides are negative reciprocals. So just think of the process. Right angles form perpendicular lines, the slopes are negative reciprocals, and then you will know what to do. Oh my gosh, can I make it? Ah! There we go. It's a right triangle because the slopes of consecutive sides are negative reciprocals. Done. Okay, one more problem here. So there's triangle ABC. I've already graphed it. Part A says that to prove that triangle ABC is isosceles. This is in your chart as well. Okay, well, what do we know about an isosceles triangle? We know that two sides are congruent, right? Well, how can we actually prove that, not on the graph, but algebraically using a formula? Well, if we want to show that two sides are congruent, that means that those two sides have the same distance, which means we're using the distance formula. So we're going to use the distance formula. We're going to do it three times, and we're going to show that two sides have the same length. So let's do, it doesn't matter what side you start with. How about we do side AB? So I'm going to find the distance of AB. Let me write the distance formula here. Just one time. Square root of x minus x squared plus parentheses y minus y squared. Okay, so let me show the full work for this. So AB, I'm going to label over AB, xy, xy. All right, so we have, I'm going to go next to it here. I'm going to start with the first point A, x minus x. So that would be negative 3 minus the other x, which is 1, squared, plus go back to that same point you used first, which was A. Y minus y would be 1 minus 3. And remember, in class, you can just put this all in the calculator. Don't type the square root button. Just type everything under it. So the first thing you would type is the parentheses. So if you put that all into the calculator, you will have 20. Now, you don't want to get a decimal answer because it's usually going to be a decimal that goes on forever, and you don't want to round. So just leave it as a radical. Now, I am going to look ahead for a second because you could leave it as radical 20, but when you look ahead, Part B asks us to calculate the perimeter in simplest radical form, so we might as well just reduce this down now. So simplest radical form is using your perfect squares. Where am I going to write this? I'll just write up in the top here. So starting from 1 and going up to 1 squared all the way up to 10 squared, so it would be 1, 4, 9, let's see, here's 4 squared, 5 squared, 6 squared, 7 squared, then we get 8 squared, 9 squared, and 10 squared is 100. All right, what's the largest perfect square that divides into 20? It is 4. So breaking it down, I would do 4 and 5, Radical 4 times radical 5, the square root of 4 is 2, so we get 2 radical 5. Okay, so that's the length of that side. Now we have to do that with the other sides. So we're going to do the distance of, let's do BC next. Okay, so again, you would plug everything into the formula. I already have the formula, so I'm just going to plug stuff right in right away. Let's start with B. So let's see, that's 1 minus, I'm doing x minus x, right? So it would be 1 minus, the other x is 2, squared, plus, go back to that first point, well, point B. So 3 minus the other y, which is negative 4. That changes it to plus 4, really. Okay, don't type the radical in, but everything else would go in the calculator. And when you do that, you get 50. And let's simplify it using the perfect squares. So the largest perfect square that divides into 50 is 25. So breaking it down into two radicals, it's 24 times 2. The square root of 25 is 5, so it's 5 radical 2. One more side to do. This is what you would do whether you want to show the triangle scalene, isosceles, or equilateral. You always do all 3 sides, and then based off of your answers, you can explain which one it is. Okay, so the last side is AC. I'll be honest, to save time here, to make this a shorter video, I'm just going to tell you what you get. So you would obviously, you know, plug everything into the distance formula, but when you do side AC, you end up getting radical 50 again, which we've already reduced down, so I'm just going to copy that it's 5 radical 2. And now we have to write our conclusion because we're proving it's isosceles. And you can tell it's isosceles because, look, 2 of the sides are 5 radical 2. So it is isosceles because, this is our conclusion. Not writing this on the exam, you actually lose 2 points if you don't write this sentence out. Okay, it is isosceles because 2 sides are congruent. And we have proved that because we have 2 sides are 5 radical 2. So 2 sides are congruent. Or you could say 2 sides have the same distance. It means the same thing. Let's do part B. This doesn't take long. Calculate the perimeter in simplest radical form. Perimeter is you add up the sides, right? Well, we have the distance of all 3 sides. We found that in part A. So I'm going to add the 3 sides. We got 5 radical 2. We had another 5 radical 2. And we had a 2 radical 5. And at this point, it's really combining like terms. So we have, you look, the like terms are the ones that have the same radical. So see how we have radical 2, radical 2? I can combine these. So when you combine these, you're adding the coefficients. 5 plus 5 is 10, but they're like terms. Keep the like term the same. Keep it radical 2. So those add up to 10 radical 2. 2 radical 5 is not a like term because it has a different radical. So I would just leave it as 10 radical 2 plus 2 radical 5. That's the perimeter.